Right, we continue here, 1.3. So we're just done with the graph question. That was a parabola, area under the curve. So here they gave you P is equal to, this is an integration problem. So now, what do? So here we got 5 over x. Okay. So in N4, well, this is the N4 paper. What you need to know here is if you have a number and that is 1 over x, so k must be a number, then the answer will be that number times ln absolute value of x plus c. Right, then, but the fact of the matter is that it's not always 1 over x. You see, when you're in N5, then you realize now that the denominator is not always x. The denominator is represented by any function of x. And if you have a derivative on the top, that means the numerator is an exact derivative of the denominator, then the answer is always ln of the denominator plus c. It's the same thing. This is basically an example. This is the proper formula. Right, so that is for 5 over x. So now, you got this 5 over x. 5 over x is the same as 5 multiplied by 1 over x. Can you see that? So 5 multiplied by 1 over x is 5 over x. That's fractions, multiplication. So when I integrate this will be 5 ln absolute value of x there. Integrate 2, that will be just 2x. We need to substitute values for 3 and then 1. Calculator, that's a fast one. Looking for the fast calculator. This is the one, yes. Right, so we got 5 ln x plus 2x. So what we do is we take the upper limit, substitute here. So let me just write that down. So that's going to be 5 ln of 3 plus 2 times 3. We substitute the upper limits. You put down a negative. Now substitute the lower limit here, which is 5 ln 1 plus 2 times 1. So let's substitute the 3 first, and I get 11,493,06144. That's when I substitute 3. Now let me substitute the lower limit, which is 1. Ln of 1 is 0, so obviously this is just a 2. So we get 9,493. All you needed to know was how to integrate that and what to do for your substitution. And so that was your 3 marks. Now, the next one. So as I told you here in previously, look, 7 marks. As long as you know those formulas, it's 7 marks. Okay. In chapter 3 with the Kramer's rule, 7 marks or 10 marks, a lot of work involved there. Trigonometry, 7 marks, it's not easy to get 7 marks. Okay, but here, the main thing is you know all the standard integrals. So let's check. First of all, each term must be ready to integrate. It must be in a form that you can integrate. So let's start with term 1. This is not in standard form. We need to know our trigonometry in order to rearrange this into a standard form. Term 2, standard form, it's fine. Term 3 is fine. Term 4 is fine. Term 5. The only problem is term 1 here. Everything else is a straightforward integral from your table of integrals, a standard integral. Okay, so what is the knowledge required here is your reciprocal identities, which are not given to you in the N4 formula sheet. It was given to you in the N3 formula sheet. It will be given in the N5 and the N6, but not in N4. So you need to know what is 1 over cosec. Otherwise, you just lost 1 mark. In fact, you lose maybe 2 marks. It's 1, 2, 3, 4, 5, 6. So I will assume 1, 2, 3. For integrating 1, 2, 3, 4, 5. For simplifying 1 and 2 marks for this one here. Because first you need to rearrange it. So what does that mean now? You need to still copy down the whole question again. Or you go straight and you write it down. So what is 3 divided by cosec? It means 3 times sine 4x. Here, that's minus 6. Remember, this is a dot. The dot means multiplication. So that is 6 times 3 to the power 2x plus 7 e to the power 3x plus 5x to the power minus 2. And here we have pi over x. Pi is like k. It's a number. Pi represents a number. So this pi over x is the same as pi multiplied by 1 over x. I'm just rearranging it. Pi is the same as pi over 1. Okay, pi over 1 times 1 over x is pi over x. Here, there's nothing to do. That's plus pi over 5 sec pi x tan pi x. Alright, so what is the knowledge required to integrate here? So, first one, we need to integrate sine of bx. And when you integrate sine, it's going to be minus cos bx over b plus c. Second one, we're integrating k a to the power bx. When you integrate k times a to the power bx, it's going to be k a to the power bx all divided by b ln a. Okay, it's much easier when you have everything in your head. Okay, and it's not too much to know. Alright, so you can see now all this thing I'm taking straight from my head, I'm not copying down from anywhere. So now, what else is the next one? The next one is 7e to the power 3x. So it's almost the same thing. This is k e to the power bx with respect to x. So when I integrate this, that will be k e to the power bx over b plus c. Is there anything else? This one, you know, there's a check. Alright. This one, okay, the last one. When you are integrating sec bx tan bx. Now this one you will not find it on the formula sheet because you need to use your knowledge on differentiation. You need to think about what did you differentiate that gave you an answer of sec times tan. It is sec because the derivative of sec is sec times tan. So when you integrate sec times tan, it goes back to its original state, which was just sec. So you have to know all this, and it's not given to you properly on the formula sheets. On the formula sheets, this is what you will be shown. Let's take this example here. Let's take this one. So the formula sheet works like this here. You got k a to the power x dx, and the answer is going to be k a to the power x all over ln a plus c. So a student who is not familiar with the proper formula will always assume that this, because here in the formula sheet, it's always an example. The coefficient of x is always 1. Alright, so that means you will not get full marks if you go and use this here without realizing that this is how it's supposed to be. The coefficient of x is b here, and the b goes here. Can you see that? So now, let's integrate one by one. So we are integrating 3 sine 4x. So it's going to be minus 3 cos 4x all divided by 4. Alright, Yes, okay, you can see that. Integrating, this is not 6 times 3 because this is not a 3, it's 3 to the power 2x. So you cannot multiply 6 times 3 because it's not 3. So be careful there. You use the formula k times a to the power bx. So that's minus 6 times 3 to the power 2x. So that's k times a to the power bx, all divided by b ln a. So that's going to be 2 ln of the base, which is 3. Right. Next one. That will be plus 7 e to the power 3x, all divided by 3. You can see there's it in front of you. Now this, when we integrate 5x to the power minus 2, it's going to be 5x and then minus 2 plus 1. So minus 2 plus 1 will be minus 1 over minus 1. What about that? This is the same as k times 1 over x. So when you integrate, it's going to be minus pi ln absolute value of x. And then this one is your sec times tan. So when pi over 5 is just a constant, so when you integrate sec times tan, the answer is going to be sec pi x. So where am I? Sec bx, all divided by b. So all divided by pi. Okay with that? Plus c, and you're done. So the main thing is you know the formula. So that's minus 3 over 4. Let me just simplify this here, but the main job is done. So what I'm doing is I'm just simplifying. So what I can see 6 divided by 2 here. Can you see that? 6 divided by 2, I wrote it as 3. I'm not going to go any further. It's a waste of time. So here, 5 divided by negative 1 is negative 5. X to the power minus 1 is, you take x to the bottom. Here, minus pi ln absolute value of x here. Pi and pi cancel. You end up with 1 over 5 sec pi x plus c, and that is your 7 marks. Right, so that is your 7 marks for this one. Let me erase the board on one side so I can continue with 2.2. So 2.2, clearly, it's not in one of these standard forms here. You can see there's square identities on the top. There's a fraction here. So, in addition to our integration, we have to know our trigonometry. You can say that. We have to know those identities. So, the numerator, straight away, we can simplify it. Cos squared plus sine squared of the same angle is equal to 1 over cos squared. 3 marks only. It cannot be difficult. Okay. So, now you need to know your reciprocal identities. Just like how you know that 1 over cosec is sine. So what is 1 over cos? 1 over cos is sec. So 1 over cos squared is going to be sec squared. Now for sec squared, you will also not find it directly in the formula sheet under integration. So whatever is not given to you directly, you need to go to your table of derivatives and think now, what did you differentiate to give you an answer of sec squared? It is tan. You must memorize that table. Okay, so you integrate sec squared, that means you're going to get tan x plus c, and there's your 3 marks. So, let's see how many marks so far. 19 marks for question 1. That was the one where you had to find the turning points and all that there and the area. Then at the moment, so that's 19 plus 7 is 26, plus 3 is 29. And once we're done with question 1 with differentiation and integration, it came to 40. You already passed the paper with knowing calculus, but obviously it's not true. It's not true that you only have to know calculus, because if you needed to know the trigonometry, can you say that? You needed to know those formulas for trigonometry. So therefore, it's not 40 straight calculus. You must know those other formulas. Then only can you get full 40 marks here. Alright, so the next one is the binomial theorem, which the formula is not given to you. Alright, in N4. Right, so the binomial theorem is what you need to know in order to expand an expression where the exponent is not a positive integer. Like if I had a plus b squared, we can expand it, a squared plus 2ab plus b squared. The problem here is that you got a plus b all raised to the power half. So this binomial theorem is done here in N4 level. You just learn how to expand. And the formula is not given to you. But in N5 it is. Because we're going to be using this in N5 under limits. Okay. So it's not that important here, but it is important in the next level. So this is the formula for the binomial theorem. A plus x to the power n. So that's a to the power n plus n a to the power n minus 1 times x to the power 1 plus n minus 1 a to the power n minus 2 x squared. This is factorial 2. Look at this pattern here that's happening here. I got a to the power n, a to the power n minus 1, a to the power n minus 2. This here is x to the power 0, which is 1, you cannot see it. X to the power 1, x to the power 2. If you want to carry on to the next term, look at it. This is n minus 1, so it's going to be n minus 1, n minus 2 times a to the power n minus 3 times x to the power 3, all divided by, this is called factorial of 3. It means 3 times 2 times 1. This is factorial of 2. It means 2 times 1, or 1 times 2. It doesn't matter which way. It can carry on and on. So they asked you to expand to 3 terms. So you're only going to go 1, 2, 3, and you're done. I'm just adding on the 4th term. Because in N5 they ask you for 4 terms. So I'm putting plus, these 3 dots mean it can just carry on and on too. So now, if you know this, then you got your 3 marks. So all you have to do now is follow. There's A here. Where you see A, you're going to replace it with A. Where you see X, you're going to replace it with B. Where you see N, you will replace it with half. Okay, it's all about substituting and using your exponent laws. So I'm going to go a to the power n, so that's a to the power half, plus n plus half a to the power n minus 1. So it's going to be half minus 1, which I'm going to write down 1 time, okay, which is minus half times x to the power 1, but my x is represented by the letter b here, so that is b to the power 1. Okay, and then we are, so that's 1, 2, 3. So that's going to be plus n, which is half, n minus 1, which is minus half, a to the power n minus 2, which is going to be minus 3 over 2 there, you can check that up, x squared, which is going to be b squared. Factorial of 2, it means 2 times 1. If I say factorial of 6, it means 6 times 5 times 4 times 3 times 2 times 1. Okay, that's a symbol to write out the factorial. Okay, if I say factorial of 5, it means 5 times 4 times 3 times 2 times 1. There is a button on the calculator where you just press factorial 2 and it will give you the answer. but you don't really need it because you understand how to write it out now. Yeah, plus you put these 3 dots here, that means this carries on, but we are deciding to stop at term number 3 because of the question, the instruction. So let's see now what's going to happen here. A to the power half is the square root of A. You clear with that? Here I have a negative exponent. I will have to take this base to the bottom. The sign of the exponent will change, and then you'll end up with the square root of A in the denominator. You're clear with that? What else is in the denominator? 2 is in the denominator. So therefore, this does not have a negative exponent, so it will remain in the numerator. Okay, I'm showing you simplification, exponent laws now. Now let's see what's going to happen here. You take that times that divided by that. You work it out. So 1 over 2 times minus 1 over 2 is minus 1 over 4. Divide by 2. You're going to get minus 1 over 8. You can check that up on a calculator. Okay. Now let's check what else. What goes to the denominator? A will go to the denominator because of the negative power. Once it goes to the denominator, it becomes a positive 3 over 2, which becomes the square root of A cubed. What remains in the numerator is the b squared. So let's write it as b squared plus, you put those 3 dots to indicate that it does carry on, but we chose to stop here. So there's your 3 marks. That's your 2.3. Binomial theorem. It's going to be used again in N5. Alright, so let's do one more. 2.4 for 4 marks. Use the quotient rule to differentiate. Now, you might be wondering, quotient rule, but the quotient rule involves a fraction. So, can I rewrite sec of x as a fraction? Okay, so now, what is the fraction? It's going to be 1 over cos x. But the fact of the matter is that sec x can be written as sec x over 1. Okay, they're supposed to, the examiner here, supposed to say, use the derivatives of sine and cos also. Because the fact of the matter is, I can do this here. I can go and say y is equal to sec x over 1, and I can call this my numerator, and I can call this the denominator, and I must get full marks because of how the question is phrased there. Right, but what the examiner was meant is this here, what we normally do, to write sec as 1 over cos. Okay, this is going to be again in N5 too, this type of question here. But now, the quotient rule. Right, so the quotient rule, you got y is equal to, let's call the numerator f of x, denominator g of x. Okay, so there's my f, there's my g, and then you know the quotient rule, dy over dx. The quotient rule is copy the denominator, which is g, differentiate the numerator, f prime, put down a minus sign, copy the numerator, differentiate the denominator, all divided by the denominator squared. That is the quotient rule. So, we know that this is 1 over cos, so my dy over dx, the quotient rule is copy the denominator, which is cos x, differentiate the numerator. The numerator is 1. The derivative of 1 is 0. Minus copy the numerator, which is f, you can see that, which is 1. Differentiate the denominator. The derivative of cos is minus sine. All divided by the denominator squared. Now, what is the answer that we are looking for? Remember, we just integrated sec times tan. What was the integral of sec times tan? It was sec. So the derivative of sec x is sec x times tan x. We need to get sec x times tan x here. Doesn't look like that at the moment, but let's see what happens. So 0 times anything here is 0. So this is out. Negative times negative here, positive. So I've got sine x all divided by cos x all squared, or cos squared x. Now, we have used the quotient rule. Right, but we need to get sec x times tan x because we know there is a standard derivative there. So cos squared is the same as cos x times cos x. We're clear with that? Cos times cos is cos squared. So this can be written as 1 over cos multiplied by sine over cos. Check it, it's a fraction multiplied by a fraction. Numerator times numerator, 1 times sine x is sine x. Denominator times denominator, cos times cos is cos squared. So from your identities, you know that 1 over cos is sec. And sine over cos is tan. So this is it for 4 marks. Right, we continue next time with the rest of this paper.